Welcome to Interact Reverse Engineering, where we'll be looking at my project files with an explanation of the most important parts of the code. If you are already a Patreon member, you'll have access to the project files. Now, in this first edition, we'll be covering this DAWLESS Audiovisual R&D with MIDI reactivity straight from an external audio hardware, using the UE5 MIDI plugin, as this topic was requested by some Patreon members. So here I have the project in version 5.4, and we'll be looking at the MIDI configuration component of the project. Now, the rest of the blueprints are code that you can learn from project 1 and 2 of the Learn by Doing series, season 2. Okay, so obviously the first thing we're going to look at is the plugin itself, which can be found here, and just type in MIDI. And this is the plugin that allows not only to receive, but also send. And so it will be cool if you're tech savvy enough with the blueprints, you could have stuff being triggered from UE and driving an external synthesizer or sequencer, which would be cool, but we'll be looking at the receiving portion. Okay, so we can just clear that and go back into the content browser. And for this video, we'll just be looking at the MIDI blueprint, which can be found over here. And you can just simply click to open it. All right, so why don't we dig in here? And that's basically the entire node graph. And what you want to look at is going to be in the event begin play. Workflow is quite similar to the OSC workflow. And so this is kind of like creating the server. But instead we go and get our devices and we loop through it in this array here. And of course, if you only have one device, you only get one. And so here you get the ID. And then this here basically creates like a receive point. And this buffer size is quite important. We'll get back to that later. And then we want to save it, just like the OSC, in memory. And if it's valid, we want to bind event on MIDI node on. Now, there are different kinds of events you can bind to. So if you just type bind event, you can do node off, node on, pitch bend, program change, control change. So some of these, they work better for USB controllers. So if you want to control visuals, using a MIDI controller, you would use these. And that's going to be how you set up a receive point. And we'll get to what is down here. Okay, let's continue with what is above down here. And so, of course, after you bind your event here, this is going to be over here, and this is where you get all the outputs, or I guess inputs, and you get it here as outputs. And so the most useful ones are going to be the channel, the note itself, and the velocity. I haven't used it here, but it will be good if you, let's say, have a pad that you have velocity on, and you want to use that to change the intensity of the effect. That will be great too. Now, instead of the message addresses, we're going to be using the channel numbers, right? And so the difference is that you want to go into your whatever device, sequencer, Groovebox, and look at what channel numbers you want to use for reactivity. And for me, it was 1, 2, and 9, and 10. So this was a chord, a synthesizer, a bass, kick, and a snare. And I save a note here. And the note I'm using for the chords. Now, there's a bit of an issue if you're playing polyphonically, like a chord, because when that is triggered, you'll get whatever 3 or 4 notes all at the same time. So it will be triggered 4 times, and you might not want that and want to treat it as a single trigger. In that case, you want to have to come up with some tricks. And for me, what I did was I went through all the chords. There were 4, and I just picked the single notes inside of the chords. So for me, it was 60 and 59. And so if it's true, we just trigger only 1 time. And for down here, for bass, kick, and snare, it's monophonic. So you only get 1 note at a time. So it makes it quite simple. And I'm not really even using the note variable at all. Okay. And lastly here, this is something that I added at the end of play. So when you quit the game, it clears the MIDI device, because sometimes I felt like the garbage collection wasn't working, which means like it's not cleared from RAM. So the next time you start it again, that buffer here is still occupied, and which creates problems while you're performing. And so we'll get to why this is important next. All right, so let's finally talk about why the buffer size is important. So think of the buffer like when you're watching YouTube, you have that gray bar, which is the speed at which packets are coming in, and you have the playhead, and when the playhead moves faster than the buffer, the video stops, right? And the exact same thing happens here. But unfortunately, for some reason with this one, once you reach the buffer, it just stops forever. So you won't get any reactivity, and you would have to exit the game and start it again, which would be a nightmare, of course, during a performance. So this number is very important. This is quite on the sparse side. And let me just demonstrate to you what takes up a lot of buffer. I have protocol open right now. You should be used to using this. And I have a teenage engineering device connected here. And if you want to debug your MIDI stuff, you want to go to preferences, make sure you select the inputs with the controller that you want, or sorry, the audio hardware that you're using. And give me a second. I'm just going to enable the clock. So the clock sync. So let me just, okay, I'm going to turn it on. Now, you can see I'm playing no sounds. I'm not playing any sounds. And this is all the messages I'm getting, right? Which is a big problem because your buffer is going to be filled with clock, right? Here. And your visuals will stop like at, depends, right? At like 8/16 bars, which would be like a big issue. So I'm just going to turn it off right now. So off. And of course, you might be thinking, wait, does that mean with this project file, I can't be sequencing external synthesizers from my sequencer? Unfortunately, that is the current state, at least, or this setup. And so this works only if you have a single device, like a Groovebox connected, and, I have this playing. I get it, stop, that's it, right? And so this allows you to save on the buffer. And I was able to make it work with 512. You might need 1024, but if you start going into 2048, this is power of 2, you will start to see your graphical performance go down. So this is going to be up to experimentation. If you somehow know a way to filter out incoming MIDI into your computer and still manage to keep sync on, that's probably how you would be able to have it work with, multiple audio hardware. But for me, I was just using one. So this is how it is, right? Okay, so that's the end of the explanation. And hopefully it was easy to understand. And if you have any questions, make sure you leave it in the comments. If you're watching this on Patreon, thank you for being a member. Also, feel free to ask questions in the community and ask some help for others as well.